I'm Anil Kumar. Welcome to my series on vectors. In this video, we'll discuss basically how to find distance from a point to planes, or distance between lines and distance between planes. I've taken 4 questions from previous test papers. Now these are the type of questions which you expect in a test paper, right? So I hope their solution will help you in better performance and also understanding these topics better. Correct? So let's take the solution of these questions one by one. The very first one here is find the point on the plane 3x minus 2y plus 7z minus 93 equals to 0, which is closest to the origin. Hence find the distance of the plane from the origin. You can actually solve this from the basic definition of planes. Question 2 is find the distance between the point and the line. Question number 3. Show that the following set of equations represent skew lines. Means the lines may not be parallel, right? But they are in parallel planes and therefore they don't intersect. So basically we have to find the distance between the two planes, right? So the first part is to show that the lines are skew lines, and second part is to find the distance between them. Question number 4 here is, for what value of k, if any, will the distance between the point and the line be 8 units, right? So these are the type of questions. Question number 4 is a thinking question. Now let's see how to solve them. The very first one is to find point on the plane which is closest to origin, right? So we are given the equation as 3x minus 2y plus 7z. Let me take 93 to the other side, right? So 93. Now to answer this question most efficiently, what you should do is you should find the unit normal vector, and then you can divide all these by unit normal vector. You will get the distance also, and you'll also get the point, correct? Let's see how. Normal vector in this case is 3 minus 2, 7. So the magnitude of this normal vector is square root of 3 square plus minus 2 square plus 7 square, which is equal to 9 plus 4 plus 49. So that is square root of 49, 53, 62. Okay, so that is the magnitude, and therefore we have unit vector, unit normal vector, as the vector itself divided by its magnitude, correct? So in this case it is 3 over square root of 62 minus 2 over square root of 62 and then 7 over square root of 62. So that is the normal vector, unit normal vector. Now to find the distance, actually how do you do using this equation? Now as you understand, a plane is defined as so if I have a plane, let's say, let me just sketch one here. Okay, so if you have a plane here, let's say something like this. Okay, now when you're trying to define a plane, you actually figure out the normal, right? I've taken it very close to this, right? You need to find out the normal and the distance. So if you define this distance d and the normal, you exactly know the plane, right? So what you see here is that the point which is closest to the origin is basically, let me call this position vector OP, will be distance time the unit vector normal, correct? Because it has to be in this direction. Is that clear? Right. Now second part is, how do we find the distance? Well, if I divide by the magnitude of the normal, I get the unit distance, right? So let me rewrite this equation. So we have 3x minus 2y plus 7z. And if we divide by the magnitude, which is square root of 62, this is equals to 93 over square root of 62. In that case, this becomes a unit vector, correct? Unit normal vector. And that becomes the distance. So from here, we know that the distance d is basically equal to 93 over square root of 62. Right. So that becomes the distance, right? So that is the distance. Now, and the closest point, which is OP, for us will be distance times the unit vector. So OP will be 93 over square root of 62 times the unit vector, which is 3 over square root of 62, 2 over square root of 62, and 7 over square root of 62. Correct? So that becomes your position vector OP, where P is the closest. So let's calculate this, right? So we'll actually multiply 93. If you actually divide if you divide 93 by 62, you can actually take the 62 common. So you get 93 over 62, right? And this is 3 to, this was minus 2, I'm sorry. So 3 minus 2, 7, right? So what is 93 over 62? 93 divided by 62 basically is 3 over 2, right? Or 1.5, correct? So the actual point will be 1.5 times these, right? So we have 1.5 times 3, which is 4.5, right? So we have 4.5 here, and we have 1.5 times 2, which is 3, right? But with a negative sign, and 1.5 times 7, which is equal to 10.5. That becomes the point P, right? So that becomes the point P, correct? So now we can write down both the answers. Our answer being that the distance D is basically equal to 93 over square root of 63, right? 62, I'm sorry, 62, right? And the point P, which is closest, will be 4.5 minus 3, 10.5. Is that clear to you? So that is how we can answer the very first question. So I hope the steps are absolutely clear, right? So we did it with the basic concept, but you could also do another thing, that is to say, you know the normal, so you can find the equation of line and then point of intersection, right? So definitely there are many different ways. Alternate will be, let me just push this page a bit forward so that I can write down the alternate method. So alternate method will be, you can find the equation of the line R, which will be from the origin to this along the normal, right? So which is basically, you can write like this also, 0, 0, 0 plus t times 3 minus 2, 7. And then you find point of intersection with the plane, right? So that is the line, and then find point of intersection with plane pi. Let's say this is our plane pi. Is it clear to you? You could do the alternate method and find the same answer. Perfect. Okay. Now let's look into question number 2, which is we need to now find distance between the given point and the line, right? So it is always through the normal, so we are going to use the cross product, right? That is kind of important to understand. Now, when you're given this line, then in that case, the direction vector is what? Direction vector is 3 minus 1, and treat this as over 1, correct? So that is a direction vector. The point given to you is what? 11, right? Now, see, this is 8, so minus 8, right? So minus 8, and this one will be 4. So this is the point given to you, correct? Now, this is point P, let us say. And we are given point Q, which is 4, 5, and 5, correct? So we have these 2 points. Let's find QP first. So QP will be 11 minus 4, let's write 11 minus 4, minus 8 minus 5, and 4 minus 5, correct? So QP will be 7 minus 13 and minus 1. So we get QP. Now to find the distance, we can use the formula, and that is that the distance D is basically equal to absolute value of the cross product of this and QP, correct, divided by the magnitude of your direction. Is it clear? We only want a unit vector in this direction. That's the whole idea, correct? Okay, so let's substitute these values to find the result. So we have M as 3 minus 1, 1, right? Cross product with we'll take the absolute value. QP is 7 minus 13 minus 1, right? Divided by the magnitude will be 3 square plus minus 1 square plus 1 square, correct? So that is what you need to calculate, correct? So let's find the cross product. So let me write this as, let's do it here. Let's do it here, then we'll write down the answer. So we have minus 1, 1, 3, minus 1, and we have minus 13, minus 1, 7, minus 13, correct? So you have to take these terms as positive as your components, and then we'll find later the magnitude, correct? So we could write this as minus times this is minus, and then we do the 13 minus, so that becomes plus 13, and here we get 7 minus and minus plus 3, and that is 39 with a negative sign and plus 7, right? So that is the cross product, which is 14, 10 and minus 32, correct? So that is what you get your the cross product, right? So the magnitude will be what? Square root of 14 square plus 10 square plus minus 32, okay, 32 square. Is it okay? So that is the magnitude which we have to calculate. The cross product will take the positive value, of course, and this is 9 plus 2, 11, square root of 11, correct? So let's calculate this answer now. Let's use calculator. So we have 14 square plus 10 square plus 32 square equals to, and square root of this answer basically is 330, and we are going to divide this by square root of 11, and what we get is 2 square root 30, correct? So 2 square root 30 is going to be the answer for us, units. You could write this in decimal value also, it doesn't matter. So which is approximately equals to 10.95 units. So I hope the steps are absolutely clear. So the idea here is to find the normal between this point and the line, and then we can easily find the distance. So that cross product gives you the normal. Perfect. So let's move on and now take question number 3. Question number 3 is, show that the following set of equations represent skew lines. Find distance between them. So there are 2 lines given to us. To show that they are skew lines, let's consider their directions. So M1 is given to us as 2 minus 1, 1. M2 is given to us as 1, 0, minus 5. And let's consider these 2 points A and B. So A and B, the distance between A to B is 0 minus 1. So it is minus 1. 5 minus 5 is 0. And minus 2 minus 3 will be minus 5. Correct? So what we need to do is to find the scalar triple product, right? So that is to say, we'll do the cross product and then the dot product. So what we'll do is AB dot M1 cross M2. So when I do M1 cross M2, I get the normal. And if the dot product is not 0, that means they're not coplanar, right? So that is how it is, right? So let's see how it works out. So let's use this determinant to find this. We have minus 1, 0, minus 5, and these two are 2 minus 1, 1, 1, 0, minus 5, correct? So let's calculate this value. So I'll calculate it on this side. So we have minus 1 times product of these two, which is 5 minus 0. And then 0 times, so we get here 0, right? And the third one, let me write here minus 0 plus. Now we have minus 5 times, so we have minus 5 times, that is 0, minus this will make this as plus 1, correct? So this scalar triple product for us is minus 5, and this is also minus 5, right? So we get minus 10 as our scalar triple product, right? So that is not equal to 0, since this is not equal to 0, right? Which is, therefore, what we have here is, so we can write like this also. We have now AB dot M1 cross M2 is not equal to 0. Therefore, skew lines. Is that clear to you? Now, to find the distance, we can actually use this scalar triple product, right? So the distance basically is equal to this scalar triple product, which is AB dot M1 cross M2. So it is helpful to even calculate or put it as a part of the question, right? Divided by the magnitude of the normal, which in our case was what? We didn't really calculate that. So we'll calculate, right? So magnitude of normal. So let's calculate magnitude of normal. Okay. So let me write magnitude of normal here. So we need to calculate what is M1 cross M2, right? So M1 cross M2 is basically equal to, let's rewrite this. So we have 0 minus 5, 1, 0, and well, I wrote the other way, doesn't matter. So we have here minus 1, 1, minus 1, 1, 2, and then minus 1. So these terms are positive, right? These terms are positive. Those are negative. So that gives you, that is 0, and that is minus of this will be minus 5. Now here we get minus 10, right? 2 times 5, and that is minus, so we have minus 10, and this is minus of 1, okay? And that gives me again minus 1, that is 0, right? So M1 cross M2 is, we have to find the absolute value of this, right? That is the magnitude, right? So M1 cross M2 is basically, okay, so let me rewrite this nicely. So that was this is minus 5, and then we did minus 10, minus 1 as minus 11, and then we did this as minus 1, okay. So the magnitude, so magnitude of this, is it clear? Right, okay. So magnitude of this will be square root of, this is 11, right? So 5 square plus 11 square plus 1, correct? So that is what we get the magnitude of this, which we are going to replace here. So that is M cross M, and then the magnitude, right? Okay, which is basically 25 plus 121 plus 1 square. Anyway, we'll place all these values here and then find the distance, right? So the distance t is equal to, we have minus 10 absolute value divided by square root of this, which is 25 plus 121 plus 1, right? Okay, let's calculate. So square root of 25 plus 121 plus 1 is basically equal to 7 square root 3. So we have 10 over 7 square root 3. Correct? So we'll do 10 divided by the answer, which is in decimals, equals to 0.824. Is it okay? So that becomes the answer for the distance between these two skew lines. So I hope you understand the concept. The idea here is to find the cross product and then the dot product. Scalar triple product is not equal to 0, and therefore skew lines. And once you do that, you can actually use this product here, because the distance formula itself is scalar triple product divided by the magnitude of the normal, right? So the normal is cross product of M1 and M2. Clear? So with that, we complete this question. Now let's move on to the next question. The question here is, for what value of k, if any, will the distance between the point P, 3 minus 2, and the line 3x minus ky equals to 6 be 8 units? You can always pause the video, answer the question, and then look into my suggestions. So in this question, we are given the point P, which is 3 minus 2. The equation of the line is what? It is 3x minus ky, let's bring it to this side, minus 6 equals to 0. We are given the distance, right? So distance formula, as you know, will be, we have to take absolute value, substitute these values. We have 3 times 3, and then minus k times y value of minus 2, minus 6, divided by the magnitude, so that we have a unit vector along this direction. So 3 square plus k square. Now this distance is given to us as equal to 8 units. So basically, from this equation, we need to find the value of k. So I hope the concept is clear, right? You can now pause the video and answer this particular question, right? Okay, so let's square both sides. Okay, so what we will do here is 3 times 3 is, let's first open this bracket. We get 9 minus becomes plus 2k minus 6 over 9 plus k square root equals to 8, right? Okay, so we can also cross multiply and square. Okay, so what we have, let's go one more step. 9 minus 6 is 3, so we get 3 plus 2k, right? So that's the absolute value, divided by square root of 9 plus k square, and all this is equal to 8. Okay, now to solve this, we are going to square both sides and find the value of k, right? So we have 3 plus 2k whole square. So absolute value, when you write this as a square, it will be positive only, equals to 8 square times 9 plus k square, correct? So we squared and then we took this to the right side. So open this bracket, we get 3 square is 9 plus 3 times 2, 6 times 2, 12k plus k square equals to 64 times 9 plus k square. Let's bring all the terms together. So we have 0 equals to, bringing k to the right side, we have 64k square minus this k square minus 12k. The constant here is 9 times 64 minus 9. Okay, so we'll need to use calculator to find the value of k. So this is basically 63k square minus 12k, and then we have 9 times 64 minus 9, which is plus 567. Now to find the value of k, we can use the quadratic formula. So k equals to minus b plus minus square root of b square minus 4 times 63 times 567 divided by 2 times 63. Okay, so that gives you 12 plus minus square root of, let's calculate this answer. So we have 12 square minus 4 times 63 times 567, and that is negative, right? So this is a negative value of 142740 over 2 times 63. Now that this being negative means no solution, not real. Perfect. So we really do not have any value of k which can give you 6 units of distance between the point and the line, right? So therefore, the answer is k has no solution. Okay. So this part, if any, is kind of important in this particular question, right? So I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.